This video is to prepare you for exercise 12.5. The first thing we meet here is the complex conjugate. So the complex conjugate is quite straightforward. If z is equal to a plus bi, then the conjugate of z is written as z bar, by the way, is equal to a minus bi. So basically what you do is to find the conjugate, you change the sign of the imaginary part. Fairly straightforward. Now it's important to understand what does that mean graphically, like on an Argand diagram. It's basically an axial symmetry in the real axis. For example, in this example here, I had 2 minus 2i down here. So find the conjugate, it becomes 2 plus 2i. So what you've actually done is an axial symmetry in the real axis. Now, conjugate is introduced here because we're going to use it for division there, and I'll show you in a couple of seconds. First of all, division by a real number. Fairly straightforward. What you do is you divide both the real and the imaginary part by the real number you're dividing by. So in this case, we're dividing by 5. So 5 into 15 is 3, 5 into 10 is 2, so you end up with 3 plus 2i. We use that method actually when we're dividing by complex numbers because we multiply the top and bottom. The method used for dividing complex numbers is we multiply the top and bottom by the conjugate of the denominator. The reason we do that is because that makes the bottom a rational number. Like in this example here, when I multiply 2 plus I by 2 minus I, it will end up with 5. And then I can go and do what I did in the previous example. Now, so here, step 1 is you write down the conjugate of the denominator, that is 2 minus I. You multiply the denominator by 2 minus I, and it ends up to be 5. Now again, if you can remember from practice, of course, it takes a while to get used to it. But when you multiply with a conjugate, you're actually working out a squared plus b squared. So here, a is 2 and b is 1. 2 squared is 4, plus 1 is 5, and you get your answer. That's kind of the quick way of doing it, but I'd practice that a lot if I were you before I start doing that. Multiply the numerator by 2 minus I, and it's done over here, and you end up with 15 plus 20i. And then I sub in those two answers, so I have 2 plus 11i over 2 plus i becomes 15 plus 20i over 5, and that simplifies down to 3 plus 4i. And that is division by a complex number. At the end of the exercise, this fancy stuff here, simplify I to the power minus 16. First step is make it 1 over I to the power 16 to get rid of the minus power. And then you, using your knowledge that I squared is equal to minus 1, you factor out the I squared there, so it's I to the power 2 times 8. And that I squared is equal to minus 1, and you work it down there to be 1. If I was doing these questions, I'd probably use the fact that it's I to the power 4 is equal to 1. So the same again here, I to the power 6 minus 16 is equal to 1 over I to the power 16. That's equal to 1 over I to the power 4 to the power 4. But I to the power 4 is equal to 1. So you end up with 1 as well. And then just one more example here. I to the power minus 31 is 1 over I to the power 31. I factor out the 4 here. That would be 4 times 7 is 28. Remainder 3. So you end up with 1 over I cubed, and I cubed is equal to minus 1. So I hope that's enough information to get you through the exercise. I think it's quite nice. Maybe some fancy stuff here at the end to do with graphs, but I think you should be able to handle it. All right.